The next special parallelogram we're looking at is the rhombus. A rhombus is a parallelogram where all of the sides are congruent. So I'm going to add in diagonal AC because we're going to be looking at the diagonals of the rhombus, and they do some interesting things. So first of all, I know that AC is congruent to itself by reflexive property of congruence. Now I can see that this top triangle, ABC, is going to be congruent to this bottom triangle, ADC, by side, side, side. I also can tell that the angle BAC and angle DAC are congruent using corresponding parts of congruent triangles are congruent. So that means that when I draw a diagonal on a rhombus, I will always be bisecting the angles. So if a quadrilateral is a rhombus, then its diagonals are angle bisectors of the rhombus. Now I'm going to draw the second diagonal, and you can see that since DAB is an isosceles triangle and AC is an angle bisector there, that means that AC is actually the perpendicular bisector of BD. And you can kind of flip it around to say the same thing for the other way, that BD is a perpendicular bisector of AC. So if a quadrilateral is a rhombus, then the diagonals are perpendicular bisectors of each other. So we're going to do a lot of right triangles here as well. So since we're using right triangles, we'll often use the Pythagorean theorem. So first of all, perpendicular bisector means that we have congruent pieces. And here are the two diagonals, they cut each other in half. That means I can say 2x minus 2 equals x plus 4, and then solve for x, and I get x equals 6. I substitute back in, and this leg here is 10, and the top leg is 10. I can do the same thing for diagonal AC. 3y minus 3 equals 2y plus 6. Subtract 2y from both sides, and I get, then add 3 to both sides, and I get y is 9. Substitute back in, and I get 24 for this leg and 24 for that leg. Well, I can find the hypotenuse of these right triangles using the Pythagorean theorem. 10 squared plus 24 squared is AB squared. 100 plus 576 is AB squared. Or 676 is AB squared. Take the square root, and I find out that 26 is AB. So I can put 26 on all of the sides of this rhombus. So that means the perimeter is 4 times 26, or 104. So for further reflection, do the diagonals of a rhombus have to be congruent? I think if you looked at our last problem just now, this diagonal was 20, and that one is 48. Is that congruent? What is the converse of the theorem where it says if it is a rhombus, then the diagonals are perpendicular bisectors? And what is that? Is that a true statement or not?